Infinite limits. This is section 1.5. Basically, we're talking about asymptotes and holes, which you learned about in pre-cal. So let's start out with an example. F of x equals 3 over x minus 2. So clearly this function is undefined at x equals 2. We cannot plug 2 in. That's an asymptote. So we can sketch a graph of this to see what it looks like. There's an asymptote at 2. So we'll just draw a dotted line there to show the asymptote. And the question we're asking here in this video, because we're talking about limits, is what is the limit of f of x as x approaches 2? So as we get closer and closer to 2, what's happening? So we'll make a table of values so we can get a quick sketch here. X, y. We'll plug in values like 3. And we'll look over here and see what happens at 3. We have 3 minus 2 is 1, so 3 over 1 is 3. So we get the point 3, which is approximately right here. We'll plug in 5. 5 minus 2 is 3, and 3 over 3 is 1. So we get the point 5, which is here. And we can plug in something like 2.5 just so we can see 2.5 minus 2 is a half. 3 divided by a half is 6. Right? So we're going over 2.5 and up 6. So you can see that this graph is going like this. And of course it's approaching this asymptote, but it's never reaching it. We could plug in 1, so now we can check to see what's happening on the other side. Actually, let's talk about this side for a second. So we can say that the limit of f of x, the limit of f of x as x approaches 2 from the right is infinity. Because as we approach 2 from the right, we're headed towards infinity on the y-axis. If we were to plug in values on the left of 2 here, so we plug in 1, 1 minus 2 is negative 1, 3 divided by negative 1 is negative 3. So we get 1, negative 3. And if we plug in negative 1, negative 1 minus 2 is negative 3, 3 divided by negative 3 is negative 1. So we get negative 1, negative 1. And we only need a couple points because we know what the graph kind of looks like ahead of time. And so the limit of f of x as x approaches 2 from the left is negative infinity. And that's why this section is called infinite limits, because as we approach the value, we're headed towards infinity this way and negative infinity this way. The overall limit does not exist, because in order for a limit to exist, as we said in previous videos, you have to be approaching a number. The y value has to approach a number as x approaches 2. And it doesn't. It goes to infinity and it goes to negative infinity. Even here, we would say that the limit doesn't exist. You can say the limit is going to infinity, but at the same time, the limit itself does not exist because we're not headed towards a whole number. Limits have to be whole number values. Okay? So that's an asymptote. Again, you learned about that in pre-cal. It's undefined here at x equals 2. And so as you approach it, you just need to make a little table of some values so that you can see where you're headed and which direction. Okay? Let's look at another example that has holes in it as well. So this. H of x equals x squared plus 2x minus 8 over x squared minus 4. And you can see that you cannot plug in 2 or negative 2 in this function. So x cannot equal 2, x cannot equal negative 2, because either way, if you square it and you subtract 4, you're going to get 0 in the denominator. So those are potentially holes and asymptotes, and that's what we need to figure out. So again, we can make a little graph here, but let's first factor this. And when we factor the numerator, we get x plus 4 over x minus 2. We can also factor the denominator because that's the difference of two squares. So x plus 2, x minus 2. And then you can see here that this cancels. And the new function now is x plus 4 over x plus 2. And so we still cannot plug in negative 2 here, which means that negative 2 is an asymptote. Because I couldn't plug it in the original function, and I still can't plug it in. So negative 2 cannot be plugged into this function. I can now, however, plug in positive 2 into this function, which would get me 2 plus 4 is 6, and 2 plus 2 is 4, so I have 6 over 4, which is the same as 3 over 2, which is 1.5, and that's a whole. Because I couldn't plug in 2 at the beginning, but now I can. So there's a hole at 2. So something is happening here at 2. So we can plug 2 in, and we get 1.5. So there's a hole right here in our graph. And of course, we can make a table and plug in some other values and get a feel for what this function looks like. We want to know what is the limit of h of x as x approaches negative 2. And we know now that it does not exist because there's an asymptote here. If I plugged in some points, I would see, just like the last graph, that it's kind of going like this. And on the other side, it looks like this. Again, all you have to do is make a quick table, plug in a few values on each side of negative 2, and you'll see what's happening there. And so we could also say, where the hole is, we could say that the limit of h of x as x approaches 2 is equal to 1.5, and that's the hole. Because as you get closer and closer to 2, the y value is getting closer and closer to 1.5. Again, these are pre-cal concepts. You learned about this in pre-calculus, how to find the asymptote and how to find the hole. Now we're calling them infinite limits, because as you approach the asymptote, you're going to infinity and to negative infinity. And we also say that the overall limit does not exist. Okay? That's basically the lesson on that. I just want to show you one more thing. I guess I'll put it here. I already have it written out. So these are just some rules. If the limit of some function, f of x, as x approaches some value c, is infinity, and some other function, g of x, as it approaches c, is some constant, I'm calling it 7, then we can say that the sum of those two functions as x approaches c would be infinity for f of x and 7 for g of x, and when you add them, you get infinity plus 7, which is infinity. So the sum of these two functions as the limit as x approaches c is still infinity, because you're just taking infinity and adding a constant. The product of those two functions as x approaches c would be infinity times 7, which is still infinity. And the quotient of those two functions would be a constant divided by infinity, or a constant divided infinitely many times. So it's going to get smaller and smaller and smaller. It's going to approach 0. So the limit as x approaches c for this function, this quotient, is 0. Okay, so those are just some general rules. I wanted to point that out because there are some problems at the end of the section that to be worked out, and it uses these rules. Okay, so that's a lesson on infinite limits.